Welcome to the IEEE 5G Transmissions Podcast, an IEEE Future Directions Digital Studio production. This is the second installment of the Future of Mobile Beyond 5G podcast with Mischa Dohler, who is an IEEE Fellow and co-chair of the IEEE 5G Technology Roadmap Committee. He is a professor at King's College London, where he is directing the Center for Telecommunications Research, and his vision is based on his experience helping design cellular systems over the past 18 years as part of university, industry, and startup jobs.
So let's spend some time to discuss these technology disruptions which are needed to keep up with past trends and which ensure that telecoms does not become a total commodity. Now, the first disruption is what we need to move from hard KPIs to perception of KPIs. Indeed, with decreasing cell sizes and increasing traffic demand, it will become more and more difficult to offer satisfactory designs on rates, outage, or delay. Now, therefore, I advocate for a fundamental change in the design approach where systems are not designed and regulated based on the measured KPI, but really on the perceived KPI. Let us take the example of data rate. In a future 5G system, the majority of the capacity will be provided via some high-capacity small cells using millimeter wave technologies. However, providing ubiquitous radio frequency coverage to satisfy such capacity increase is both technically challenging and economically really prohibitive. Now, one possible solution here is to use predictive analytics on different metrics, such as consumer data, user behavior, user movement behavior, or speed of movement. That would allow one to implement, for example, enhancing caching techniques, which will allow provides different service continuity in the case of coverage holes, and buffer the to-be-watched Netflix or YouTube video until the next access point is reached. Now, several technical challenges need to be addressed here, where the most notable being that the application layer needs to communicate with lower layer so as to execute the best strategy. Now, a strategy based on the use of software-defined networks, we call them SDN, for dynamic quality of service management can be further enhanced with predictive analytics to provide accurate on-demand resource allocation. Now let's move from user perception to the first segment in the tech chain, which is spectrum. Spectrum has been managed over past decades in two regimes. License, that means an operator purchases spectrum rather expensively, or license exempt, that is, anybody can use it as long as simple rules are obeyed. Numerous studies have established that spectrum as a whole, however, remains poorly utilized. What about managing spectrum in an unprecedented way through distributed ledgers, like used for blockchains? This combines prior work on dynamic spectrum management, TV white spaces, spectrum databases, and blockchain. We would reach a new level of atomized spectrum ownership at a spatial and temporal granularity really not seen before. And you could be an operator. So could I. So could be a small business or university or factory. It all could be seamlessly managed in a trusted environment, ensuring maximum capacity and minimum interference. Wow! Now let's talk about the next tech element, the radio access networking architecture, where we have pioneered a novel atomized and decoupled architecture. Traditionally, due to homogeneous cell sizes, downlink and uplink were associated to the same base station. We have found out that under heterogeneous settings, decoupling both, meaning where uplink goes to a microcell and downlink comes from a macrocell, not only gives great capacity gains, but most importantly decreases outage by a whopping 1 to 2 orders of magnitude. Now, concept is called DUDE, and we believe to be a transformational design in cellular. Now let's move on to the core network. Well, I've been advocating for years for a thinning of the core networking infrastructure. Now we have the core network today in 4G because we had it in 3G. And we had it in 3G because we had it in 2G. Right. And the reason the core network was there in 2G is because at those pre-internet times, none of the operators believed that there will ever be a general internet which would be able to carry the voice traffic reliably enough. 30 years on, we still use the core network and thereby greatly limit the scalability of the wireless edge, which, because of above discussions, limits the rates to be delivered. Now, capitalizing on this insight, as well as recent trends to virtualize the enhanced packet core, The next step ought to be to push the entire cellular core network system to the edge, first into the emerging cloud RANs and later into the edge devices, which this approach would allow us to scale and importantly significantly decrease the end-to-end delay between operators. And finally, I'd like to introduce the concept of self-designing cellular systems. I haven't told anybody this before, so listen carefully. Now, with the advances in artificial intelligence in AI, software-defined radios and networks, the SDRs and SDNs, and robotics, there's no reason why cellular systems couldn't evolve their own design and deploy themselves. Whilst research and best possible technology solutions can still be done by humans, that means you and me, future cellular systems should be able to scout the publication and innovation databases such as IEEE Explore, extract the most promising solutions, self-upgrade these using SDR and SDN technology, and or self-deploy them using autonomous drones. Now, this would allow the standardization cycles to be shortened from years to days, if not minutes. A real disruption on the horizon, hopefully to kick in by 2030. Now to finish off. For these technology disruptions to take place, significant changes in the underlying innovation ecosystems are advisable. Without going into great details, I believe we first need a much stronger industry co-design approach. And second, we need to open up standards to accelerate the standardization cycles. And finally, I thought for you to ponder about the following. Don't you think we should innovate the regulators so they can properly regulate innovation in the 21st century? Thank you for listening, and please do reach out via Twitter or email if you have feedback or ideas. Thank you very much.
Thank you for listening to this edition of the IEEE 5G Transmissions podcast. Discover more about the IEEE 5G initiative and inquire about participating in this effort by visiting our web portal at 5g.ieee.org.